In this video, I am going to demonstrate creating a custom ontology to relate custom dictionary concepts to each other. I will show how to use these custom relations as well as UMLS relations in tree view and through relationship detection. I'm going to use a cartridge called Drug Disease Relationships to demonstrate, and you can see I already have 4 artifacts in this cartridge: a drug dictionary, a disease dictionary, a drug disease attribute set, and UMLS 2020 AA, which is the Unified Medical Language System version 2020 AA. Opening up the diseases dictionary, we can see that I have various different types of diseases. As the domain expert, I know that some of these diseases could be considered children of others. For example, both non-small cell lung carcinoma and small cell carcinoma of lung are both types of malignant neoplasm of lung, or types of lung cancer. Therefore, within this domain, I would consider small cell and non-small cell lung carcinoma to be children of malignant neoplasm of lung. I would like to represent these parent-children or hierarchical relationships within a custom ontology. I also want to represent relationships between concepts in this disease dictionary and concepts in my drug dictionary, as I know that some of these drugs are actually used to treat some of the diseases in my disease dictionary. I've actually already created an ontology for this purpose, which defines both the hierarchical relationships between concepts and the semantic relationships between disease concepts and the drugs that can be used to treat them. When creating a custom ontology, we have a very specific format that users are required to follow so that we can properly interpret the defined relationships. This format is outlined in depth in our documentation, so I recommend taking a look at that if you decide to create a custom ontology. To use the relationships I've already defined, I must import the ontology I've created into a new artifact so that I can use it in the configuration editor and in ACD. I am going to create that new artifact here by clicking on Import Ontology. I'm going to name it Drug Disease Relationships. The owner is me, and I am actually going to be importing it from a CSV. If you do not have the concepts in your ontology already defined in existing dictionaries, you could click this checkbox and define a dictionary name. Then, once this ontology is imported, a dictionary would also be created with the concepts that were in the ontology. However, since I already have my concepts represented in my drug dictionary and disease dictionary, I do not need to do that. Instead, I will browse and select the ontology I wish to use. It's going to be a comma separated file, and I'm going to click Import. You can see now over on the right side that I have an ontology called Drug Disease Relationships added to my cartridge. Now that we've imported all of those relationships, we have to somehow link those dictionaries to the ontology so that we know which concepts from which dictionaries are being referenced by the relationships in the ontology. To do that, we can go to the dictionary settings. So clicking on Edit Settings from that hamburger menu in the top right, down here at the bottom is the checkbox to use this dictionary in a custom ontology. After clicking it, it will pre-populate the ontologies in your cartridge for you to select from. I only have drug disease relationships in my cartridge, and that is the one I want to link this dictionary to anyway. So I'm going to save that. Then I also have to link my disease dictionary to the ontology as well and save that. So again, what this is doing is the ontology defines the relationships between concepts, but we also have to tell ACD in the ACD configuration editor where to find the definitions of the concepts that have the relationships defined in the ontology. So we're telling ACD and the configuration editor that the ontology relationships are defined for concepts in these dictionaries. So saving that, we now have that linkage created. Now that they are linked together, we can start using those relationships, which I will show you first in my attribute set. I already have 2 attributes created. Now I just need to fill them out. First, we'll start with the attribute lung cancer drug. What I would like to do with this attribute is find this attribute if any concepts that are lung cancer drugs are found. Now, as the person who created this dictionary and ontology, I happen to know that I defined treated with relationships between relevant drugs and the concept malignant neoplasm of lung. So I'm going to start by finding that malignant neoplasm of lung concept. I'm going to click on the one that starts with a T, as the concepts that start with a T, CUI, are the ones from my custom ontology. So clicking on malignant neoplasm of lung, I can then click on this tree view icon to open up our ontological tree view. You may have seen this in previous videos, but the tree view essentially finds any ontologies that concepts in that field have relationships defined in, and then it is going to display those relationships and the related concepts to you for you to traverse. So you can see initially on open, we are looking at the malignant neoplasm of lung concept. If we look to the right, it has the different types of relationships that are defined for this concept, and children is highlighted. So right now we are looking at concepts related as they are children of malignant neoplasm of lung. And the 2 child concepts are small cell carcinoma of lung and non-small cell lung carcinoma. However, as I said, what I am looking for is concepts that represent drugs that treat this malignant neoplasm of lung. These are going to be those semantic relationships, as they are not hierarchical, but rather contextual. And so now you can see, once I click on semantic, we are seeing different concepts. In this case, we are seeing tamoxifen and cisplatin. You can see along the right side that the relationship types are actually listed out. In this case, the only relationship type we have is treated with, and I could click on this, and if there were more concepts, it would narrow down the concepts that were returned to just those that have a treated with relationship type. In this case, that is all of the concepts. And hovering over the node of the concept will actually also show you those relationships that are being returned, which, as I mentioned, is treated with. So these are the concepts that I'm actually looking for, as I said, because I'm looking for concepts that are drugs that treat malignant neoplasm of lung. So I'm going to click on the circle to select those concepts. I'm going to unselect malignant neoplasm of lung because I no longer need it, and I'm going to save. Now you can see that the 2 concepts in the match values field are those 2 drugs which treat lung cancer, and I can save that. So that is one way that we can use the tree view. Now I'm going to show you how to use it to select hierarchical children. So I'm going to fill out this heart disease attribute. For this attribute, I would like to be detected whenever a concept for heart disease is found. I know, again, that I had a concept in my custom dictionary for cardiovascular disease. So first I'm going to pull in that concept, and again I will be opening that tree view. So you can see cardiovascular disease has several children defined in my ontology. It has coronary artery disease, and then coronary artery disease actually also has a child called myocardial infarction. I want to, again, find this attribute if any heart disease concept is found, which includes not only cardiovascular disease, but also its children, which are types of heart disease. So you can see along the top that there are various different actions that clicking or double clicking or right clicking will do for you. So I am going to use this one right here. The option of right clicking will select the concept that you are right clicking on as well as all of its children. So if I right-click on this root node, you are going to see now that coronary artery disease is selected, and myocardial infarction is also selected. Now hitting save, you can see all three of those concepts are in the match values field. And if any of those concepts are found, then the heart disease attribute will also be detected. I can also use concepts not only from my custom ontology and dictionary, but from UMLS. As UMLS not only defines concepts, but it also defines relationships between the concepts. So I am going to, this time, pull in the concept for cardiovascular disease from UMLS, and I'm going to click on the tree view to open that up again. So you can see at the bottom there's two different tabs in my tree view. These are the two root nodes of the concepts that were in my match values field. You can see that for UMLS, cardiovascular disease has a lot more than just two children. It has a lot of children, and those children have a lot of children, and so on and so forth. Now, I could do like I did in my custom ontology, right-click the root node and select all of its children. Now, that is going to populate all of those CUIs in that match values field. It's going to be a lot, and it's going to be very overwhelming. Also, I, as the domain expert, might in the future want to update my cartridge to a different version of UMLS as a new version is released, and we update the versions that we have in the configuration editor every year. If I do so, some concepts in the new version could be added as children to cardiovascular disease. Some of these children might actually be removed as children of cardiovascular disease, and I would have to manually come in to this attribute, reselect all of the children that are maybe new, and try and filter out which ones are actually no longer children. That can be very time-consuming, very difficult, and a pain to keep track of, especially if you have a lot of concepts where you are wanting to select a lot of children. Instead, we have added a capability that allows you to dynamically include children of root concepts. You can see this option at the top where it has a checkbox that says automatically include children of root CUI. You are allowed to choose the depth to which you want to include the children and as well the sources you want to include those children from. Because again, there are many different sources in UMLS that define different relationships and concepts. So if you wanted, you could only pull in children that were defined in certain sources. So I am going to click this checkbox, and I am going to actually increase the depth and include children to depth 2. Now you can see instead of being colored that teal color from before, all of the children are colored a bright green color, which indicates that they are dynamically included. And if we scroll down to find the root node of cardiovascular diseases, you will see that it is green with an outline of teal to show that it is automatically including its children. So dynamically including the children means that if you choose to change your version of UMLS, instead of manually having to update the children for this concept, our tool will, in the background, resolve the children of this concept to the depth and sources that you select. So after saving, you can see that all of those many children were not pulled in and enumerated in the match values field. Instead, that root node of cardiovascular diseases is colored bright green and has this 2 indicator along with the asterisk, which indicates that you are including the children of this concept to a depth of 2. So instead of, again, having all of those children enumerated in this box, we will be doing the resolution of those children in the background for you so that it will be automatically updated with new UMLS versions. I'm going to save this attribute, and I'll show you how you can change that UMLS version. If you, in the future, decide to switch to a different version of UMLS, you simply have to change the version of UMLS that your attribute set is using. You can do that in the settings for the attribute set, in this hamburger bar, and in the edit settings modal. And you can see at the bottom that there is a UMLS version. Right now, we're pointing at UMLS latest. I could change it to any one of these, and you can see as the help text says, this version that you specify in the artifact will be the version used to resolve the children for any concept selected to automatically include their children. So if I change to UMLS 2019, we would use UMLS 2019 to find those children of cardiovascular disease and detect that attribute. I'm going to set it to UMLS 20AA for this attribute set, as that is the version that I am using in my cartridge, and I am going to save that. Now that you know how to use ontologies in the tree view, you can also use those in the relation detection annotator. This annotator uses the dictionaries and ontologies in your cartridge to find concepts that are related to each other in unstructured text. For the relation detection annotator, you must first create a relationship configuration artifact to tell the annotator which relationships you would like to detect. I'm going to create that new artifact, a new relationship configuration. I'm going to call it drug disease relationship configuration. And at the bottom, you have to select which ontology you are configuring with this relationship configuration. Now, I can either configure my custom ontology or UMLS 2020 AA if I would like to detect UMLS relationships. I am going to actually select UMLS just to show you what that looks like in a relationship configuration. I can then click on it in the right sidebar to show you the artifact. You can see at the top it's telling you which ontology it's targeting, and the only fields you really need to fill in are the relationships you would like to detect. If no relationships are specified, then it will be detecting all relationships possible. Now for UMLS, that's a lot of relationships. You can either type in this box to find relationships you're interested in, or clicking on this icon at the right will list all of the relationships. Like I said, UMLS has a lot of relationships. So especially if you are looking to detect UMLS relations, it is recommended that you specify the relationships that you are interested in. Now I am still interested in those treated with relationships. So I am going to type treat into the type ahead, and it's going to show me the different relationships that have treat in the name. So I'm going to select a few of them and pull those in. And you can see now if we scroll down and look for those ones that have treat in them, that they are going to be grayed out because they are already added to the relationships that we're looking for. You can see also if I hover over them that I could click here to add them to my relationships I'm interested in. You can see after clicking that it's now in the tags input, but I'm going to delete that one as that's not what I'm interested in. Now that I have selected all the relationships that I am interested in, I can click the Save button to save those edits and go to Preview, where I can show you what the relationship detection looks like. First, we need to make sure that relationship detection is actually selected as an annotator to run in our flow. We can either select it in a flow that we have saved or in the Select Annotators flow. You can see it's actually already selected. This is because we automatically select the annotators to run in the Select Annotators flow based on the artifacts in your cartridge. And since there is a relationship configuration in your cartridge, we assume that you would like to run relation detection. Since it is selected, I can simply run this annotator, this flow as is, and you can see that now in the right findings sidebar, if we collapse these other two summaries, there's a new summary section called Relations. This is showing you all of the relations that have been found in your text and the type. You can see that we have 2 may be treated by relations and 2 may treat relations found in our text. I'm going to show just the may treat relations. So you can see these are being highlighted in that orange color that they show in that sidebar. And if I hover over one of the concepts, you can see that we have may treat coming back as the type. We are having it is over the cover text for myocardial infarction. In the concept it is coming back over is myocardial infarction, and the related concept is heparin porcine. So what this is telling us is that our relationship of may treat is coming back for myocardial infarction as it is related to heparin porcine via may treat. We're actually getting 2 of these may treat relationships, and that is because there are 2 concepts over heparin that are related to myocardial infarction via may treat. There is the CUI of heparin porcine, and there is the concept for heparin. So both heparin porcine and heparin may treat myocardial infarction. This is how you can use custom ontologies as well as the UMLS Metathesaurus to define, explore, and detect relationships between concepts.